Hello together. Let's talk about Kibana-Vega. First of all, let me ask you some questions. How or what is the main matter of having a good visualization? Why is it important to have a good visualization? And why can't you even just go through logs and get your informations together? Because I strongly believe that a graph can tell you more than 1,000 logs. It is important to have a good graph which you can get all the informations which you need together without browsing through multiple dashboards or through logs, etc. So it's important to get all those information which you need into one graph. So let's go through the agenda. First of all, we will have a look at Vega as an application. Then we will go further to problem and solution, like what is the problem that Kibana want to solve with Vega? And then we'll have a couple of examples. Till this point, we will keep it really simple. So it's nothing very technical. And after that, we will go to the functions and features of Vega. So that'll be interesting for DevOps guys. And then we will go to a demo which we will create or try to create a visualization based on Vega. That will be a simple one. So, and then QA, yeah, QA, I will more or less know QAs. So let's get first to the Vega as application. Vega is an open source project. It started around February 2013 or something. It's based on the D3.js library. D3.js is a very famous library for visualizing, for visualizations, and it is well known in the web application and developments. And the actual output of a Vega is actually nothing more than HTML element of Canvas or SVG. So what it does is actually the Vega takes all those parts which are written in D3, and with Vega you're able to write a declaration, just a declaration. You don't need to program anything. It's just a declaration which you need to get your visualization out of it using D3. So problem and solution. Why did Kibana decided to take Vega into their visualization portfolio? So that is because at the beginning there were a lot of standard visualization. Kibana is well known for their visualization features, and it is pretty simple one. But you can click it together in some seconds, and you would have all those information which you wanted. But sometimes you would have more complex needs or goals which you need to achieve with the visualization. For example, you want to have a visualization which you can put together 5 different type of information, and will not be able to do it with a standard visualization. That is the point where people started to create plugin. They wrote plugin which they added to Kibana, so that they could visualize much more complicated things. For example, with the D3 library. But the problem with plugins are, as you all should know, if Kibana brings a new visualization, if Kibana brings a new update, so it is hard to check the plugin. Okay, is it still working with the new update? So maybe you need to write something else. So you always need to maintain the plugin based on the updates which on Kibana. And that was the point that Kibana said, okay, let's get Vega into it. So people won't need to use a further visualization plugin. So it will resolve all the use of a visualization plugin. And Vega is really, I will say 99%, because I'm not really sure about it, but I never found a case which is not implementable into Vega. So you can customize it on a very, very wide area. So let's do some examples. Let's get here to the dashboard. This will be things which you can achieve with Vega. And for example, this dashboard, a status dashboard. I think that's one of the main cases which you want to do if you have monitoring use cases. And they'll be like, I got a bunch of checks, which would be possible to view, but I want to have aggregated it on based of some of the attributes which it has. And this will be something like this. I got a map of Switzerland, then I got 3 points where my data center would be, for example. On Zurich, I would have VHM components, OpenStack components that are checks. So at the moment, in these groups, everything's working fine. So if I go to storage, then I would know, okay, I got it. My storage is running on EasyDue node 94 to all these nodes. And I would have storage-based checks, which is storage check 3, 0, 1, 5, 4, and 2. And now I actually want to know if one of these checks fails and would get a warning or an error. I want it to propagate to the first level. That's actually the thing which you can achieve with Vega as well. So let's try something out. If I would go to, I don't know, heat, for example, doesn't really matter. Let's check Zurich node 24, heat check 0. This will be this one at the moment. So 24 and check 0. Let's go to the developer tools and maintain that one and modify that one. So Zurich node. I'm not really good in memorizing those things. 24 and heat check 0. I would have 2 of them. Let's take another one. Let's take 36, for example. It's 2 as well. That didn't work with that one. Let me check something else just for sure. Check status. I still have 3. That's fine. Let's take this one. This is Zurich node 36. Check 4. 36. Check 4. So let's modify this one. At the moment, this one is set to, this is this one which you are checking at, and the status of it, you would see at the dashboard status, that's 45. So everything from 0 to 5, you can define it by your own, but in this use case, it's defined everything from 0 to 50 is fine, and everything to 50 to 100 is, 51 to 100 is yellow, and everything up 100 is, would be, so colored red. So let's put it to 55. And if you go here and refresh the dashboard once again, you would see the check now, the Zurich node 36 heat check 4 is yellow. And you will see that as well on this level and on the first level as well. So you can propagate it to the top level. And also, if I would check on the Alton Keystone, and let's take Alton 2 Keystone check 0. Alton 2 Alton 2 check 0 keynote. So it's not the right one. I wrote something wrong. Keystone, yes, sorry. Keystone check 0. So this will be this one. Let's put this one on an error state. For example, 120. That is done. And let's go to the first level. Let's just have a look. So Alton got an error now. This will be the first view that we will see. You'll just click down, you will drill down, and now you will see, okay, in Alton, I just got Keystone, which is having an error. So I go once more down, and I will see, okay, it's Alton 2, Keystone 0, which is having an error. So that's actually one thing which you can do. And it is achieved with, you have done multiple dashboards, which you put together by hypertext referencing. And with each drill down, you will add filters to each dashboard. So that's how, if I would delete all those filters out of here, I would have a bunch of checks here. So for example, like this is actually the lowest level with all those checks. But I'm just adding filter to it that I can only view at those things which I want to see. And for example, with Vega, you can also write filtering on the client side. For example, like this, I only want to see everything from Zurich, for example. Or I only want to see strings which have 2 inside. Or I only want to see cinder checks, for example, and so on. I can also say I don't want to see things which are okay at the moment. So a lot of things which you can do. Let's go to dashboard and let's see the next one. This will be a simple one. This is like a dashboard which is visualized on a customer requirement, because those people wanted really to have a dashboard for the operation teams which are really visualizing those things which they needed. For example, these are all VMs running on a machine, on different physical machines though. Physical machines are this one, BA node 2, BE node 3, Alton 1, 2, 3, and so on. So each block is representing a VM, and all those attributes which are coming with those VM, you can show them inside those blocks. For example, on which VM that it is showing me the position. And for example, the availability zone attribute of this one will be the filled color, so it's zone B, as you can see as well. On the third part on the array will be availability zone B. And with the stroke color, you can show a different information. You could also go a step further, and you could instead of showing rectangles, you could visualize symbols. For example, circles, stars, and so on. So you could put multiple information. I'm sorry for that. You could put multiple information together as you like. Okay, let's go back. Let's have a look at Vega example. These are a bunch of really good examples. They're not all from me. Some of them I've just took together from the Vega library, Vega example library as well. This one is one just that we have written, and this one will be like it's showing the whole map, which are the data is collected from multiple data sets. One data set will be showing which kind of things that you want to, which kind of countries that you want to show, and what the form of them looks like and what the position is. So the data will include Switzerland, for example, from how the form of Switzerland looks like and where it is positioned. And I just actually got here one thing that's actually showing the year, which you can select with the range selector, and it will show which countries are in the European Union to that moment. So you can just put the slider on, and it will turn everything green. So you can have really conditions which you want to color those, countries. And I made a little bit fun about this. I mean, this is actually a pretty interesting subject at the moment. Great Britain don't know if they're in or not. So you can do a lot of things. You can play around very well inside here. So let's go to the next one. This is also showing. This is one out of the Vega example library. And let's see. On the left side, you would have a life expectancy, and on the bottom line, you would have the fertility. So how many children that they had. And for example, all dots are a country, and those countries are, if it's a light blue, then it's from America, or if it's a yellow one, then it's like from sub-Saharan Africa, and so on. So for visualizing and very interactive visualization, you can say here, you can just drag these buttons, and all those other points will change the year as well. So you're changing the year with drag and drop these through their line, which they can, and all those other points will be changed as well. So it is really customized. You can really customize the interaction which you want to do with the visualization, and that is at some point very important for a lot of companies. Now let's skip this one. It's not really important. This is also, for example, a funny one. It's just it's also taken from the Vega example library, and which does is actually nothing more than showing which airports are connected together. These are all airports, and the size of the airports, if they have multiple flights or if they just have some flights. And on mouse over, you can see which of those airports are connected. I mean, you can think about those same information also in an I2 infrastructure, which components are connected together, for example. This is actually also something similar. I just got a filter which I can say which country I want to look at, and then you will fetch together how many airports there are, and then which flights would they have. So there's a flight from Geneva International Airport to Madrid, for example, or this will be a flight to Tesla Airport in Belgrade, or this will be to Paris, Charles de Gaulle, and so on. So you could really put together, this is a Sankey diagram, and you can really, normally it is used for showing network traffics, but you don't have to do it only for network traffic. You can also put other things together. So it's really customizable. That's the thing that I want to say about it. So I think I've shown all of examples. So I say, yeah, you can also filter them. You can also have a lot of things on it. So let's go further with the presentation. Let's get a look at what Kibana-Vega function actually does. Kibana does actually nothing more than, you would have on the left side, you would have the data. You would have a JSON declaration in the middle and the visualization. So what Vega is doing is actually taking each data in the data set and transforming it to an information, to a visualization information. So on this use case, you would just take it and say, put all those categories on the x-axis and the connected amount of them on the y-axis. That's actually everything what you're doing here. So what it does is making a rectangle out of it and positioning it. That's actually everything. Okay, and let's go to the next one. This will be one of the use cases which you have already shown. And as I told you, you can also fetch your data from multiple data sets. You can have the information for the countries from one data set, as you can see here, and you can have the information about the European Union entrance time and exiting time from another data set. That's also possible. And it's also doing nothing else than rendering those information and based on the second data set coloring each countries and on the range selector as we have seen. So let's get to the features of Vega. So data is one of the features which you can have. That's actually a function that's a declaration part which you need to fill. And here it's actually, you can get your data from multiple areas. For example, you can do an Elasticsearch query, which is pretty good to use in Kibana. And you can also get your information from an URL. Or you can hard code it inside the Vega declaration. Or you can also get a query and reuse the response where you already have. So you don't need, for getting the same information and modifying it to different types, you don't need to fetch the information multiple times. You can just copy that and modify it to something else. And these data which you get, this can be a JSON. That's actually pretty common in Vega to have a JSON. That's also the default. You can have a comma separated value, or a tab separated value, or a delimiter separated value. So delimiter, you can especially say which delimiter is used to separate those values. And you can have multiple data sets, as I told you. So okay, transforms. Transforms are actually used to modify the data. So, for example, you get a bunch of data from an Elasticsearch query and you want to modify it. So the main goal will be to modify it to visualization information, like you want to have the color of it inside maybe, or you want to have, if you're modifying all the data to a pie chart, so you want to know what kind of angle it should be, which kind of angle, or etc., which kind of angle each arc should have, and so on. Or you can also create new fields. Or what else you can do is also filtering. So you're having a data set and you can set up a condition which data needs to fulfill that it will be still visualized. So you can say, as we have seen in the status dashboard, with the hide OK. So everything that is not OK is visualized, and everything that's OK would be thrown away, for example. And what else can you do? You can also do aggregation, and these all things, the transforms, that are done on the client side. So you won't get any server load for that. For example, you can aggregate it once again. Elastic queries are much easier, performance. It got a better performance, but you can also do it. You can also do it on the Vega side. For example, you can aggregate. You can create a. You can build up a sum or an average value of an attribute. But just for saying it once again, the normal use case of transform is actually to get the data into visualization informations like position and so on. Signals are actually used in Vega as variables. So you can bind those things to you can bind you can bind signals to HTML input, for example, and they will get an automatically two-way binding. So you can get it to a select box, a checkbox, or a drop down, a text filter, for example, and so on. But you can also bind it to events like mouse over, clicks, and so on. So all kind of HTML events which exist. So scales is actually having a similar use case like transforms, because transforms you really modify the data. With scales, you're not modifying the data. You're just saying on which kind of rule you want to put up an information. So it's like actually nothing else than a lookup. So you will say, for example, you would say you will have a data set of VMs as we have seen before in the example. And now you want to say, okay, I got 4 different type of availability zones, and I want them to map each to a color. And that rule, that mapping to a color, that attribute mapping to a color rule, that will be saved in each scale. And that's the thing on rendering the visualization. You're gonna say, okay, fill up this field or fill up this box depending on this scale which I've built up. So it will check, okay, I got the value availability zone A, so which is the mapped color? It will be yellow maybe, so I'll take yellow. So you're not modifying the data, you're just saying on what kind of lookup it should take, almost. And these things you can do it with, you can take numbers to hide. There are a lot of things which you can build up a scale, like a lookup or mapping. And for example, let's imagine you want to visualize a scale. That will be actually legends or axis, for example. Marks. This is actually the visualization building blocks. This will be like geometric primitives which you have, like rectangle, lines, axes, arcs, all those things which you have to create a visualization. And the next step will be to parameterize those primitives. So for example, the stroke color, or the filling color, or the stroke type, or the position, the size, and so on, opacity, for example, and so on. So marks are actually nothing else than all those, each drawed part on a visualization, which is basically depending on the data. And the encode feature, that's actually a very, very good thing which you have in Vega. So all marks are have an encode property which you need to declare, and there you can use enter, update, exit. These are the most 3. There are some else, but the enter is actually the first time if the data is visualized, and update will be like what to do after an event occurred or so on, and exit would be what to do with the visualization block, visualization mark, as my data has been deleted or removed. So this is building like a life cycle of the visualization during the rendering, almost. So I think that will be, yeah, get to the conclusion. So what have I talked about? That'll be like, what is Vega used for? Vega transforms the data to visualization elements and their attributes. That's actually what it does. And you can customize those visualization elements and attributes. So what kind of things the data should be get to. And Vega is used when all standard visualization reach their limits. So things which you can do with the standard visualization, do it with the standard visualization. But things which you can't, or things would need further tolerance or multiple capabilities, use Vega. It is really, you can get all those things which you can do in standard visualization, you can get it in Vega as well, and much, much more. Remember the 99% of customizable. So, demo. Let's build a visualization. Let's get here. Let's see it here. So Vega is actually coming with the normal Kibana installation, so you don't need to do anything else for it. So let's create a new visualization, then you will say Vega. This will be the thing which you have. Let's just delete this. I just prepared something which we could use. So let me take this away. Okay. This will be the first part. This will be, it's actually nothing happening than the title which I've defined here, number of docs from environment. Oh, let me first tell you what I actually wanted to do. I actually wanted to do nothing else than this will be the discover part of Kibana, which we have a look at the index. And yeah, what I'm actually doing now is I'm having a check status index, which you have the this environment. So let me just take this first away. This will be all the docs which I have there. So, and the thing that I want to do is I have 3 different type of environments attribute here. So it'll be sewage, Alton, and burn. So now I'm interested in, okay, how many docs that I have with sewage, or Alton, or burn. For that, we could just visualize it to a bar chart and show it each environment on the x-axis and number of docs on it on the y-axis. Let's do that in Vega. So what I've done here at the moment is I just declared where to get the data from. And the thing that I'm doing here is I'm giving the data a name. And then I'm saying, okay, this will be my check. We can also have it, you can also have it just here. Yeah, I think this is the same one which I'm doing. Yeah, this is actually the same. This is the query which I'm doing there in the Vega visualization as well. So I'm saying make an aggregation. The name of the aggregation is environments. It's a terms aggregation on the field environment. So take each different values which it have and bring me 10 of it back. And the response will be something like this. I got my aggregations, the environments aggregations with the buckets. And I got the Alton, which is 1037, Zurich 1025, and Bern with 938. So, and the next part which I'm saying here is as well, I'm only interested in this part of it. So I'm saying aggregation, environments, buckets. And this is actually nothing else than get me aggregations, environments, buckets. So I'm just working inside Vega with this after this format declaration which I'm doing. And now for ensuring that I want to know on do I really have the data? I don't see anything here, so I want to have the capability to check it. So what do? I'll just go to the developer tool of Chrome, for example. What is this? Yes, let's see. Throw this away, and let's. Yeah, you have a Vega debug variable where you can view signals, data, and so on. So I can I can fetch the information inside a data, with its name. I've declared it as data1, and I just got this information as a JSON here. I got the key, it's open. I got the doc count, that will be the number of elements which I have. So it's the same information which I found here, but in Vega at the moment. This is inside Vega. Okay. Now let's get to the next step. What do I want to do now? I want to, let's skip the signals, we'll come back to that later. Now I want to build up some scales. So what I will be doing is, after the data part, I will put in a scales. You won't see anything, so just you're defining scales, and the scales, I got 2 scales at the moment, and the name of the first scale is X and the name of the second scale is Y. So for the X scale, everything what I'm saying is use the band type, that's one provided Vega feature, the type of the scale, and the domain, the input value for mapping something will be in data1, so it will be here on field key. Okay, let's go to here. This will be my data1, and I'm looking at key. So I will map all these Olten, Zurich, and Bern into what? I will map it to, I'm gonna mapping to the width. So width is actually a signal, so a variable from Vega, provided from Vega, which is a default signal, and that is actually the width of the visualization. So that will be from here to here. If I resize it, it will reduce. That's actually everything. So what I'm saying is map all those key values which you have there, so Olten, Bern, and Zurich, to the width. And here in Y, as same, pretty similar, map everything in doc count to the height of it. So everything in doc count, so that will be 1037 to the height, 1025 to the height, 938 to the height. That'll be the thing I'm doing. So now, as I told you last time, you can visualize scales with legends or axes. Now we have to use axes for that. So let me get that information. I prepared this as well. So now I have visualized the scales which I've built up. So I got 3 values in it. So that will be Olten, Zurich, and Bern. And in the height, I got something to 1037. That was the maximum, I think. So I got to 1000. Let's go to the next part. I'll be creating a mark. So let's just only put this one at the beginning. Marks. So now I've just built nothing more than a rectangle. So my first mark is a rectangle from data1. And now I come up with the encode part. That will be like how to render it on different levels. So at enter part, so when my visualization are built up for the first time. Update, this will be after an event occurs, and hover will be hover will be one of those extra things which I have mentioned before. It will be like if you're going with the mouse over it, what to do with the mark. So here it will be like hover, make it red. So it works. And on update, there will be, now it's an event happening, and that's hovering, and it makes it red. And if I leave my mouse, so that's also an event which is occurred, and then the marks get re-evaluated, and that makes it still blue again. This will be this field, making it still blue again. If I would take this away, or for example, if I would take this away to this part, it will be still blue, but I can go on it and then it will stay red. So I need to have those things in update, which I want to reevaluate it after an event. And all other things which I'm doing here, for example, the X, I'm saying for X of the mark, so the X position, use the scale x, which I have defined, with the field key. So what it does is actually nothing more than getting this data, and I will say, okay, use the scale x, which I've already mapped Alton to a special x position, and this will be Alton, so put that mark just there, so Alton will be positioned here, and so on. For example, and the width will be band 1, that's some kind of default which you have, and y and y2. Y will be like take the scale y with field doc count, so the value in doc count will be the y, and y2, so y is here, and y2 is set to 0, and that will be the baseline. So now we can do one more thing here. That will be like we want to see on hover what information which you what the doc count is. So you're not seeing it at the moment here. Let me refresh this. You're not seeing this at the moment, so you're not seeing the effective value of it. So we want to have that as text shown above the rectangle, and we can put it like this together. So I'm just doing nothing else than putting up a text. I'll say the encode in enter, align it to center, baseline, the color of it, which it should have, and on update, it's actually nothing else than from the signal tooltip, get the key of it. So that'll be the X position. And the Y position will be tooltip, that's also signal. We need to create that. We don't have that have it at the moment. And tooltip get the doc count, so that will be the value that I want to show. And plus it's not the value that I want to show, it's just the position of the text, sorry. And that would be like offset -2, so show it above it. So you're rendering everything from the top down. So if you do minus, you will go up. And the text which I want to show, that will be tooltip.docCount. Okay, so if I render it now, it won't work because it can't find the tooltip. So I don't have any signals defined. So we need to do that, and that will be here. What I've got, that was the skip signal which we skipped at the beginning. So we can put it in, and you see at the top of it, you can see the value fetched and showed. And for the tooltip, which you actually with the signal tooltip, you're actually doing nothing. Then the name of it is tooltip. The value at the beginning is nothing, and on. So on rectangle, mouse over, update it with datum. Datum is actually nothing else than the value which was used to create that mark. So that's an attribute which you're fetching. So that's an instance of the data which used to create that mark. So if you go with mouse over on it, you're filling into tooltip the data which has been used to create this. And that's how you can fetch it later with tooltip.key. With you will get here tooltip.key will be Alton at the moment. If I go to here, tooltip.key will be Zurich. So that's how you change the position of it. And so on. Yes, that's actually it. Excuse me for this, I had to cut out the last part of the video because it had some audio troubles. Anyway, I'm done with the presentation, and I hope I could help you with providing some good information to have an intro into Kibana-Vega. And if you have any feedbacks or questions about it, then don't hesitate to contact me. You can find my email on the slide. And yes, thank you very much.